I'm going to start today by reviewing some factoring. And when we're factoring, we need to think about really three methods. There's more, but really the big methods are greatest common factor, split the middle, and difference between two squares. And technically what we should do for every single factoring problem is we should ask ourselves, do we have a greatest common factor? Well, in this first problem, do we have a greatest common factor? We do. There is a y in both of these terms. So we're going to factor out that y. When we factor out y, we're dividing. X squared y divided by y leaves us with x squared. And y divided by y is 1, and yes, we need to write the 1 on that. But what we just did is we factored out a greatest common factor. Well, as we take a look at this, can we factor any more? And hopefully you're nodding your head yes, because x squared minus 1 is the difference between two squares. There's a minus sign in between there, which is a hint. X squared is x times x. Square root of x squared is x. The difference between two squares. X times x. Square root of x squared is x. Square root of 1 is 1. It's the difference between two squares, different signs. And now we've completely factored this expression. Again, there's three methods for factoring. Greatest common factor, split the middle, difference between two squares. And once again, always ask yourselves, do we have a greatest common factor? In this particular problem, do we have a greatest common factor? And it looks remarkably similar to the last one. We have a y. Once again, greatest common factor. 2xy divided by y is 2x. Y divided by y is 1. There's still a minus in between those two. Can we factor any more on this one? No. We don't have a squared in this problem. There's nothing else that we can do. So this one was just a straight greatest common factor problem. When we look at problem number 3 here, we ask ourselves, do we have a greatest common factor? And we do not. And then another thing that we can notice is that there's an x squared, that's one term, a 4y squared, that's another term, and there's a minus in between those two. And this one happens to be, once again, a difference between two squares. And we can take the square root of x squared. It's x times x. We can take the square root of 4. It's 2 times 2. We can take the square root of y squared. It's y times y. And difference between two squares, different signs. And that's all that we can do for that problem. Difference between two squares. So you can probably guess as we get to problem number 4 what type of problem there are, since I've been talking about 3. Greatest common factor, difference between two squares, we've done. We haven't looked at the split the middle. And on problems 4 and 5, what we're actually doing is we're actually solving those, but we still need to know how to split the middle before we get to that point. And just a reminder, when we split the middle here, that there's a 1 in front of that x squared. What we're going to do, 1 times 2 is 2. And the factors of 2 are only 1 and 2. So we write down the x squared term, we write down the minus 2. And how are we going to get negative 1x from our 1 and 2? Well, it's going to be 1 minus 2. And it doesn't matter which order you write these down, but I wrote down plus 1x minus 2x because we split that middle term. And now we can factor by grouping, and eventually what we're going to do is we're going to be solving these problems. But we need to focus in on the factoring before we can solve. And the greatest common factor in that first group is x. And when we factor that out, we've got x plus 1. We had 2 x's, we took out 1. X squared divided by x is x. 1x divided by x is 1, and yes, we need to write the 1. Be careful, because there's a minus in between these two. Our greatest common factor in this second group is a 2. And when we factor that out, negative 2x divided by negative 2 is x. Negative 2 divided by negative 2 is positive 1. And hopefully what we see at this point is that x plus 1 and x plus 1, those are the same value from each group. So we end up with x plus 1 times x minus 2 equals 0. We have split the middle, and now we're going to use our factors to help us solve for x. And I hope that you can tell me right from here that x equals negative 1 and x equals positive 2. But if you can't tell me, the way that we get those values is we take x plus 1 and we set it equal to 0. And x minus 2 and we set it equal to 0. And then we solve. X equals negative 1 and x equals 2. Split the middle. Problem number 5. The same kind of idea here. We want to split the middle. 2 times 1 is 2, so same values here for splitting. We only have the factors of 1 and 2, just like the previous problem. But how are we going to get negative 1? Because there's a 1 in front of that x. Well, it's going to be 1 minus 2. It does not matter how you put your values in. I usually go in order, so I would say 2x squared plus 1x minus 2x minus 1. But if you wrote the 2x's, the 2x terms together, and the 1x terms, then the 1 terms together, I don't know how to say that exactly, it's fine. You're going to end up the same place. In fact, I made it kind of hard by setting it up this way. But the greatest common factor in the first group is simply x. And we factor it out. 2x squared divided by x is 2x. We had 2x's, we took 1 out, we still have 1. And again, we had 1x, we took it out, we still have a 1. Over here, be really careful, because there's a minus sign in front. But the only thing that's in common between 2x and 1 is a 1. But there's a negative on the outside. Negative 2x divided by negative 1 is positive 2x. Negative 1 divided by negative 1 is positive 1. And in general, when we split the middle, when we're factoring by grouping, what we get in the first parentheses is what we should get in the second parentheses. Luckily enough for me, we did. And we've got a 2x plus 1. And we have an x minus 1. The x from in front of the first parentheses. The minus 1 from in front of the second parentheses. We've split the middle, but ultimately what our goal here now is that we want to solve. And once again, I hope that you can tell me that x equals negative 1/2 and x equals positive 1 without doing any work. But if you have to do some more work, there's nothing wrong with that. 2x plus 1 equals 0 and x minus 1 equals 0. We subtract 1 from both sides, and we get 2x equals negative 1. Divide both sides by 2, and x equals negative 1/2. On the other term, the other factor, not quite so difficult. We're going to add 1. Now let's take the factoring and apply it yet again to our trigonometry. If you notice the title of the notes, it says Solving Trigonometric Equations by Factoring. When we solve a trigonometric equation by factoring, we still have our 3 basic values. In fact, even the grouping could be considered another type of factor, but greatest common factor, split the middle, difference between two squares, are pretty popular in solving a trigonometric equation by graphing. Also do notice that we're going to be giving the general formula for our solutions, and the general formula means that we're either going to add plus pi k or plus 2 pi k. So again, when we look at a factoring problem, we ask ourselves, do we have a greatest common factor? Well, I see a cosine theta in the first term and a cosine theta in the second term, which means that we do have the greatest common factor, and it's cosine. When we factor out a cosine, we're left with sine squared theta minus 1. Cosine divided by cosine is 1, and yes, we need to write the 1. And if we want to get technical on this problem, we really could use the difference between two squares on that sine squared theta minus 1 equals 0. But I want to show you how we have been solving it rather than do it with the factoring. But once we've factored, and we have factored, we didn't factor completely, but we did factor, we can take cosine of theta and we can set it equal to 0. And we can take sine squared theta minus 1 and we can set it equal to 0. And we probably do need to show some work, but think about the unit circle as we're solving these once again. And something that you might see when you compare your work to mine is I oftentimes draw a grid, and I actually drew it right in between the two problems on your paper. And I put in these values on our unit circle. This point being 1, 0. This point 0, 1. Over here to the left is negative 1, 0. And down here is 0, negative 1. And the only reason that I put that in there is because quadrantals sometimes are difficult for students. Cosine is an x value. So where on our unit circle is cosine 0? Well, what we see is that the x value of 0 is at the top here, which is pi over 2. And it's also at the very bottom, which is going to be 3 pi over 2. And once we find those two values, though, because we're finding the general formula for all of these, we need to ask ourselves, can we draw a straight line from one angle to the next? And we can draw a straight line from one angle to the next. Because we can, we write the smallest angle plus pi k. That will take into account the 3 pi over 2. But that's only one of the factors. We need to look at sine squared theta minus 1 equals 0. We have to solve this equation. So we'll start by adding 1 to both sides. And we get sine squared theta equals 1. So we have the trig function by itself, but it's squared. So we need to undo that square, which is we're going to take the square root of both sides. Now when we take the square root of both sides, squaring and square rooting cancel each other out, so we get sine of theta. But over here, when we take the square root of 1, which by the way we can, it's plus or minus whatever the square root is. I want to emphasize that plus or minus when we're taking the square root. But let's go back and look at our picture now, because sine on the unit circle are the y values of the function. So we're looking for the y values where we have 1. Well, it just so happens to work out that where sine is 1 is up here in the top of our picture, and it's also in the bottom of our picture. and we already have the straight line drawn to it. So ultimately what happens is, with respect to both of these factors, we get the same value. Problem number 2. Again, when we're looking at factoring, we always need to ask ourselves, do we have a greatest common factor? Well, just like the previous problem, we have a greatest common factor. It's cosine of theta. And when we factor out a cosine of theta, we're still left with 2 sine theta. And cosine theta divided by cosine theta is 1, and we do need to write that 1 in this problem. So it happened to be another greatest common factor problem. And once we factor this trigonometric equation, we're going to set each equation equal to 0. Now, luckily enough, we just talked about cosine of theta equals 0. And we found out in problem number 1, example 1, when cosine of theta equals 1, we get pi over 2 and 3 pi over 2. And it just so happens, as I pull the screen back, we were able to draw this straight blue line between those two values, which means that this answer to this factor here is pi over 2 plus pi k. And that's when we set cosine of theta equal to 0. But we have 2 factors to work with. We've got the 2 sine theta minus 1 equals 0. We are going to add 1 to both sides. And we've got 2 sine of theta equals 1. It's 2 times sine of theta. Inverse operation is to divide by 2. We end up with sine of theta equals 1/2. That's when you might want to take out your left hand and figure out, well, where does sine of theta equal 1/2? Well, if you're doing the hand gesture, we're folding in the ring finger. We've got one finger underneath that. That ring finger is represented by pi over 6. And I want to go back to all students take calculus. Pi over 6 is in the first quadrant, and all of our trigonometric functions are positive in the first quadrant. But where else is sine positive? Well, it's also positive in the second quadrant. And what's the pi over 6 angle in the second quadrant? 5 pi over 6. So pi over 6 is somewhere around there. And 5 pi over 6 is somewhere around here. Can we draw a straight line between those two? As I didn't draw a straight line between the two, it kind of makes a V shape. And because we're not drawing a point from one, not drawing a line from one point to the other, we're going to take pi over 6 and add 2 pi k. And we're going to take 5 pi over 6 and we're going to add 2 pi k. And these are the other two solutions in general form for our trigonometric equation. So as we flip our paper over and look at this particular function here, the nice part about it is that it's already in factored form. And when we solve this problem, what we're going to do is we're going to take each of the factors and we're going to set them equal to 0. It's already factored for us. We're going to set secant of theta minus 2 equals 0. And cotangent of theta minus 1 equals 0. And we can put them in the proper form. We can add 2 to both sides. We add 2 to both sides. We get secant theta equals 2. But I don't know where secant of theta equals 2. What I do know is that secant has a reciprocal of cosine of theta. And since I'm working with the reciprocal, I need to take the reciprocal of 2, which is 1/2. And then we can use our finger gestures again. Where cosine is 1/2 is at pi over 3. Cosine is also positive in the 4th quadrant. And what pi over 3 angle is in the 4th quadrant? It's going to be 5 pi over 3. Well, if we look at the circle here, and I don't even draw it like that, I just go like this. Pi over 3 is here. 5 pi over 3 is here. Can we draw a straight line from that to that? No. And because we can't, this part of our factoring is going to be pi over 3 plus 2 pi k and 5 pi over 3 plus 2 pi k. So now we have the values for part of our factoring problem. But let's go back and look at the other value over here. Cotangent of theta is -1. Well, cotangent of theta equals -1. We don't really know that much about cotangent, but let's convert that to tangent. And before I do that, I need to really go back and let's move the 1 over to the other side. So now we have cotangent of theta equals 1. But we need to know tangent. Or we know more information about tangent. So tangent of theta is also 1 because the reciprocal of 1 is 1. And just as an aside, it was 1 over 1, so if we flip this, this is still 1 over 1. And then, this is probably our biggest weakness. Do we know our tangent values? But where tangent has a value of 1 is at pi over 4. And all students take calculus here. Tangent also is positive in the 3rd quadrant, and the pi over 4 angle in the 3rd quadrant is 5 pi over 4. And once we know those two, the thing is, pi over 4 is here, and 5 pi over 4 is here. Can we connect those 2 points with a straight line? And as you see, we can. So our other value that solves for theta here, the general angle, is going to be pi over 4 plus pi k.